Hey, Geometry Lovelies. I hope you can hear this. The last time I made this video, I heard that I couldn't be heard. So I hope that you can hear this. We're trying it again. All right, well, let's get into it. So it's lovely that you clicked into this video. Thanks for doing that. I hope it helps. Why don't you pause it right now and solve this problem right here? Go. All right, welcome back. Let's solve this problem together, shall we? So we've got a right triangle, and we have a side length and an angle measure, and we want to find another side length. Specifically, wow, that was hard to say, specifically the hypotenuse of this right triangle. So we're going to use some trigonometry on this, because trigonometry is where you mix sides and angles together. So the first step is to identify theta, and theta is that 32-degree angle over there, and directly opposite theta is a side. We're going to call this the opposite side because it's opposite theta, and then we're going to identify it with an O. Across from the right angle is the hypotenuse. We're going to identify it with an H. And then that third side that we haven't really done anything with, we're going to call that the adjacent and label it with an A. Labeling your right triangle sides can really help set up your equation for solving a trig problem. Now the next thing to do is notice what you have and what you want. What I have is information about the opposite side. What I want is information about the hypotenuse. I don't care about the adjacent side at this particular time. So what I have and what I want is going to help me pick the right trig ratio, and there are three. There's the sine, there's the cosine, and the tangent. The sine can be remembered as being the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. We have to pick one of these. Our choice will come from what we have and what we want. We have the O, we want the H, and so the sine ratio is the one that has both the O and the H in it. And cosine and tangent are not useful. So this SOH is trying to remind us that what it stands for is the sine of the angle is the opposite over the hypotenuse. The sine of the angle is the opposite over the hypotenuse. And so we're going to write that in math language. The sine of the angle is the opposite over the hypotenuse. We just pull the information from the triangle into that equation. The sine of the angle is the opposite over the hypotenuse. And from there, we can solve this equation. Now, what's lovely about these equations is that it's really just pushing buttons on a calculator from here, and my calculator's all the way across the room, so while I talk to you, I'm strolling to the other side of the room to grab a calculator. Okay, here we go. So I just need to figure out sine of 32, and that's about pushing buttons, and I get 0.53-ish. Now you could look that up in a trig table as well. In the trig table that's on Google Classroom, you could look up 32 and then look in the sine column. And right next to 32 will be a 0.5299 probably, and we're rounding to 0.53. So that 0.53 equals 9 over x. Now we want to clear the x out of the denominator, and so we're going to multiply by both sides. Multiply both sides by x, creating that cancellation right there. We have 0.53 equals 9. Oops, 0.53x equals 9. Now dividing both sides by 0.53 gives us a value for x, which is 9 divided by 0.53, 16.98-ish. And that's centimeters. And there you go. That is the length of the hypotenuse. So identify your sides, figure out what you have and what you want, use that to pick the correct trig ratio, use the memory device, SOHCAHTOA, to get yourself an equation, and then solve the equation. That's how you do these. So now would be a good time to update your notebook. You might want to write yourself some questions, write yourself some summaries, make a new note page. Let's do this. So we're going to use Trig to solve real-world problems today. The topic, using Trig to solve real-world problems, should make it into your table of contents of your notebook. And then the essential question today is, how does right triangle trigonometry apply to the real world? So let's see some examples of that. Right triangle trig is often used to find the height of tall objects or how far something is away, but it's used for much more than that. Right triangle trig shows up in so many things I just can't even tell you. In fact, I've been telling you that it's so prevalent that it's in your calculator. The sin, cos, and tan buttons are in every scientific calculator because everybody practically who has anything to do with angles or finding out how tall something is or how far away something is uses trig at some point of their life. Now there's a couple of things to keep in mind. There's these things called the angle of elevation and the angle of depression. The angle of elevation is the angle measured from the horizontal looking up. So this guy down here is looking up at this guy over here, and he's looking at him through what's called an angle of elevation. Now, an angle of depression is going to be the opposite way. That is going to be the angle measured from the horizontal my board's freaking out. Or it's not writing. My pen's not writing. Come on, y'all. Might have to pause here and see what's up with the board. Be right back. All right, I fixed it. The angle measured from the horizontal looking down. Why did I capitalize that L? Who knows? Anyway, that's an angle of depression. And so you're going to see those words, and what you just need to know is that one is looking up and the other one is looking down. So here's an example. Oh my gosh, another pause. Hold on. Hi again. All right, let's do an example. The angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. To the nearest foot, how far is the sailboat from shore? So this is a very typical use of trigonometry in the real world. Sailors need to know trigonometry so they don't dash their boats on rocks that are close to shore. All sailing charts have the height of various lighthouses in the area, and sailors use instrumentation to find angles of elevation, and they compare that. They use some trig with the height of lighthouses, and they can figure out how far away they are. Now, of course, they have electronic instrumentation that takes care of that for them most of the time, but no one who spends a lot of time on the water doesn't know trigonometry, because your electronic equipment goes down all the time. I actually worked on a fishing boat for a little while, so I know what I'm talking about. Anyway, here we have the problem. So we have a theta of 16 degrees, and across from theta is our opposite side, which measures 121 feet. Over here we have the hypotenuse, and down here we have the adjacent, which is the side we're trying to find, the distance. Knowing that we have the opposite and we want the adjacent, we're going to have to pick the correct trig ratio out of the three: the sine, the cosine, and the tangent. The sine, you remember, by opposite over hypotenuse. cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Noticing that we have the O and we want the A, we're going to pick the tangent ratio, making those other two unnecessary. So now we're going to use TOA to help us set up the equation. The tangent of the angle is the opposite over the adjacent. And there you go. There's our equation. Now I'm going to take tan 16 and put it into my calculator. And I get, oh, hold on. In this calculator, I have to put in the 16 first and then press tan. It's really important to know what your calculator does and what it needs. So I get 0.29, and I could look that up in a trig table as well, equals 121 over d. Now I'm going to multiply both sides by what's in the denominator of that fraction, causing this cancellation here, and I have 0.29d equals 121. And then dividing both sides by 0.29, I get that d equals 121 divided by 0.29. 417.24, 417.24 feet. And that is how far the boat is from the shore. Alrighty. So that's one use of trig. Here's another one. A knight in distress is being held captive in a tower. His damsel in shining armor is on the ground below with a ladder. When the damsel stands 15 feet from the base of the tower and looks up at her precious knight, the angle of elevation to his window is 58 degrees. How long does the ladder have to be? So our knight is up in a tower, and down here is the ground. And then his damsel, trying to save him, is on the ground, and it looks like she is 15 feet from the base of the tower. So this is 15 feet. Now she's trying to go up to the top of the tower with a ladder, and so we're trying to figure out how long this ladder needs to be. The angle of elevation from her to the window is 58 degrees. And so we now have all the pieces. We have our theta of 58. Here's our right angle. Our theta of 58, and across from that 58 is our opposite side. Across from the 90-degree angle is our hypotenuse, leaving this side to be the adjacent. We have the adjacent. We want the hypotenuse, and so that we're going to use that to pick the correct trig ratio. The sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite over the adjacent. Since we have the A and we want the H, cosine is what we're going to use this time. So the cosine of the angle is the adjacent over the hypotenuse. And here we go. Now we can solve this. Cosine of 58. In my calculator, clear, 58 cosine, I get 0.5299, so let's say 0.53, equals 15 over x. Multiplying both sides by x, as per usual, clears those out, and I have 0.53, x equals 15. Dividing both sides by 0.53, x, or the length of the ladder, needs to be 15 divided by 0.53, and that is 28.3 feet long. And there you go. Same process as always. Set up your right triangle, put the pieces in the right spot, label your sides, pick your ratio, make your equation, and solve it. Here's another one. According to a Chinese legend from the Han Dynasty, General Han Xin flew a kite over the palace of his enemy to determine the distance between his troops and the palace. If the general let out 800 meters of string and the kite was flying at a 35-degree angle of elevation, how far away was the palace from General Han Xin's position? So, according to this legend, we've got this kite, and it's flying over a palace. So the kite's up here, and the palace is down here, the ground is down there. And then if the general let out 800 meters of string, so here's the general, and the string going up to the kite is 800 meters. And we're trying to figure out how far away the palace is from the position of the general. And when the general's looking up, he's looking up at a 35-degree angle. So there you go. Let's see, yeah, we're trying to find this one because we're trying to figure out how far away that palace is. And there's your right triangle. So let's start solving. We've got theta of 35. Across from that is the opposite. Across from the right angle is the hypotenuse, leaving the one marked x to be the adjacent. We have the hypotenuse. We want the adjacent. And so we're going to pick the correct trig ratio. We remember by remembering so, ka, toa. And we find the one that has the a and the h, and it is, again, the cosine ratio. These two are not very useful right now. So the cosine of the angle, the cos of 35, is the adjacent x over the hypotenuse 800. Now, just because the number's in the bottom doesn't mean we've done anything wrong. It happens sometimes because we always have to put whatever is in the adjacent, in this case it's x, over the hypotenuse, in this case it's 800. So now we're going to take cos of 35 cos, and that's 0.819, so I'll say 0.82 equals x over 800. Now I'm still going to multiply by what's in the denominator. This time it's going to be by 800. These cancel, and 800 times 0.82 is 656, and that equals what's left over on the right, which is x, which is exactly what we're trying to find. And so we are looking at, is this meters or feet? Meters. So it looks like they are 656 meters away from that palace. There you go. All right, one more. One day after school, you and your friend are walking past Panther Stadium. Your friend says, "I'll bet those stadium lights are 100 feet tall." You say, "Let's find out." You and your friend stand at a distance of 30 feet from one of the lights and measure the angle of elevation at 64 degrees. Is your friend right? If not, how tall are the lights? So here's our stadium light. And here's us standing 100, no, not 100 feet, distance of 30 feet away. And we're looking up at an angle of elevation of 64 degrees. There's our right angle, and we're trying to figure out how tall are the lights. So that right there. So here's our theta. Across from theta is the opposite. Across from the right angle is the hypotenuse, leaving this side to be the adjacent. We have the adjacent. We want the opposite. And so we have to pick the correct trig ratio. Sine is so, ka is cosine, toa is tangent, and we have the adjacent and we want the opposite. So that looks like a tangent ratio thing to me. So then we set it up. The tan of 64, the tangent of the angle is the opposite, which is x, over the adjacent, which is 30. And then we're ready to solve. Tan of 64 is punchable into a calculator. 64 tan 2.05 equals x over 30. And then to clear out that 30, we're going to multiply by on both sides. 30 times 2.05, oops, that's not right. 30 times 2.05 is, oh, come on. 30 times 2.05 is 61.5 feet equals x. Done. So no, our friend was not right. And how tall are the lights? 61.5 feet. There you have it. All right, friends, that's a look at how you can use trig in the real world. I hope you can hear this video a whole lot better than the last one. Your practice is on quizzes, but it is not a quiz. Have a great day. I'll see you next time.